Thank you very much for the introduction. Thank you for staying at the last few presentations of the program and listening to my presentation, although I think this little change might have confused a few people. Hopefully, I will be speaking about an interesting topic for you. If you have a data lake, what are our analysts going to do with it? This is a question I raised. And why did I raise this question? Why did I not raise what are our data scientists going to do with this? Because there are not too many data scientists today, and we would like to democratize a bit the usage of the big data environments. And this is why I raised how can our analysts get to this to the data lakes? If you have already built one, find the information that is there, evaluate the value of that information, and be able to discover the value and share the value with others. This is the topic that I would like to speak about. And first, I think I would like to continue with a question. How many data scientists are sitting in this room? Can you please just raise your hands? Okay, that's a nice company. Quite a few data scientists are in the room, so there's a lot of brains here. I think this is a known fact that there are many data scientists missing from the market today. Analytic companies tend to agree that we have numbers for the US only. I don't have numbers for the Hungarian market, although there's a friend who is doing some assessment on that. He doesn't have the results yet. In the US, at least, analyst companies tend to agree that there's a shortage of 100,000 between 200,000 data scientists are short on the market in 2017. This is a huge number, I believe, but if we compare it with how many things a data scientist needs to know, there are no other class of workers today on the market who would have to know so many things as a data scientist. Have to understand some mathematics, statistics, definitely, programming, computer science, a lot of software that is involved with bringing out value from the big data, and also has to understand the business goals to be able to mine out the value for the company along those business goals of the company. So I saw a few hands, quite a few hands in the air. That is nice for the people who consider themselves data scientists, and that is very good. How many people would like to be a data scientist? Can you again please just raise your hands? Okay, even some more hands, good. I would also like to be a data scientist if I look at the next slide, because the next slide speaks about how much a data scientist earns on the market. And yet again, there are different numbers coming out from the analysts, but they tend to agree that data scientists have a very good salary, beginning somewhere around 104,000 by one analyst and 113,000 by another one. And there is a Bloomberg director, the Stanford University director who told to Bloomberg recently that in the metropolitan areas such as New York City and Silicon Valley, the starting salaries for a data scientist is around $200,000. So I'm also volunteering for a data scientist. Of course, I'm learning all of these nice products that are involved into big data management and big data analytics. But honestly speaking, I was born in a different era, and most of the analysts recently, until the very recent years, have used SQL, the SQL language, most of the time to create their reports that were demanded by the management to allow them to monitor the performance of their companies. These SQLs ran on many time data warehouses, not just Oracle, of course, many types of data warehouses, but it was easy to use. So a lot of people could understand the SQL queries, learn how to build even a complicated SQL query, and fulfill the need of the management. Of course, to be able to do that, the data had to be prepared into one place and prepared for analytics into one place. That is obviously not the situation with big data, because with big data, we want to include a lot more information. So now the word is more complicated for the analyst. And it is not easy for the analyst to write a few SQL queries from this point on and fulfill the needs for information that is growing with magnitudes in the lines of the businesses of today's corporations. So to even extend this problem, I would say that the applications are fine. If somebody wants to build applications on top of this heterogeneity, NoSQL databases for some purposes, Hadoop data stores, and relational databases, and whatever databases, there are tools that enable these people to do that, specializing on bringing out data from these data stores with good performance. So building applications is okay, but most of the cases you want to use these environments for analytics that makes things complex because of these fragmentations. Why? Because with analytics, we want to give the opportunity for the users, even for the business users and the analysts, to be able to iteratively use these systems for analytics. So find the information that is supporting the analytics of a topic, then choose the attributes that are relevant for that certain investigation. Make the necessary changes on the data, because data is not clean normally, and also is not in the format that is easy to be analyzed. And then be able to discover the value out of that and be able to share this value with others. This is a complex task. So many organizations now have this big animal somewhere, Hadoop. Hungarian organizations began to build a lot of systems like this, mainly initiated by some of their lines of businesses. But I am working on a bigger geographical area consisting of East Europe, Central Europe, Russia. I see many projects starting that are involving Hadoop. So why are these analysts in the right-left corner looking so desperately? Obviously, because it's not easy for them, as I said, to bring out the value of such a system. There's an uncertainty in the data. They are not even familiar with all of the data gathered in these data stores. They are not sure that if they begin an investigation, if they begin to go after a topic, what is the potential value that resides in the data? It requires a significant manipulation of the data to get there at all to be able to begin the analysis. So the problem is with Hadoop at the moment is that yet again, as it was with the data warehouses in its beginning of their life cycles, that the most of the efforts are typically spent on evaluating and preparing data instead of being able to analyze the data. And some speakers already referred to that. There is a tool complexity that the users have to face. A lot of different tools, even more than this, what I show here. There were extremely crowded slides with dozens, actually around 100 different tools that can be involved into managing and analyzing the data. So I think we can come to the conclusion, and we came to the conclusion already, that working with Hadoop, involving big data into the corporate analytics is a complex task, and early tools are only for the experts. So this is why there's a huge demand for the data scientists, I believe, because they expect that the data scientists would know all these tools, and we'll be able to navigate with these tools to get the business value for the company. But this is also not true, because I think data scientists know just part of these tools. They begin to work with something, they begin to like something, then they reach the borders, the boundaries of those tools, they choose another one. But to know all of these tools is probably is impossible, but still a lot of people are trying to get as much information about these tools as you can. So just let's see what are the most important steps that needs to be done by anyone, should they be data scientists or business analysts, whatever kind of business users, if they want to use the data in a data lake. Finding the data is the first step. Exploring what is the meaning for the current investigation of that data is the second one. Performing some transformations on the data to make the data first of all usable from the point of view of reliability, from the point of view of data cleanness, and to transform it into a format that is easily consumable by the tools that can make a discovery on the data and then can share the findings of the data. So what if we could have a single intuitive interface to be able to do all these things, all these important processes of working with the data in a big data lake. I think now we are already going towards that direction, making things more simple for the business user, for the analyst, mainly for the business analyst. And I would like to introduce just one tool for that, an Oracle tool, of course, that is named Oracle Big Data Discovery. This is a framework that enables all these important processes: finding, exploring, transforming, discovering and sharing the findings with others within one single framework, supported by nice user interfaces, not command lines, not difficult parameterized commands, but rather using everything on a user interface. So the 4 steps of this, the 5 steps of this process are all covered by this tool. So let's take just a look at what kind of support the users can get from big data discovery within these important steps. So finding the data and exploring. I already began to discuss that if a data lake is set up, a business analyst, if a business analyst is turning to that data lake with the intent of analyzing a problem with the help of this, first of all, he or she has to be able to find the data. That is not trivial, because we want to use multiple subjects in a data lake. So obviously, in the first steps, we are setting up a single subject data lake for the first step. But for the use of the whole enterprise, it is meaningful to set it up for the use of the from many LOBs, from most of the LOBs, and therefore finding the data in such a data lake is not trivial. And then exploring the meaning of the data is again another task that the analysts and business users need help with. Unfortunately, this screenshot doesn't show doesn't show you probably sitting at the back what this tool is capable of doing, but it can create a catalog, a rich catalog of all the data that is residing in Hadoop, and makes it searchable for the users, for the analysts, with familiar search and guided navigation functionality. And then it also enables to see, to get recommendations from the program to what kind of data can be in correlation with the data that the user has chosen so far. In the second step, it is even more interesting what the analysts have chosen with the finding step are all visualized on the screen using simple visualizations that are adjusted to the nature of the data. The tool creates statistics on the attributes and shows the user visualizes the attributes by type, sorts the attributes by information potential, so there's an intelligence behind this, and lets the users assess the attribute statistics and the data quality and the outliers of the data. And it then offers a scratchpad also to uncover correlation between the different attributes, and this is the way how a user can easily assess which data in the end will have to be used in the final steps of the investigation in the discovery phase. It can also detect the anomalies in the data. That is very useful because this way we can assess the data quality. And the benefits of these steps being supported on a user interface are the users can get started fast, choosing which data to deal with, visualize the data that they have chosen very, very quickly, quick and dirty, and then they can justify which data should they proceed with, or and again, a very important thing, they can judge whether they should proceed at all with that investigation, because, as said, such investigations do not lead always to a good result, to a beneficial result for the company. It's better to know in the beginning that we either don't have the data that supports a certain investigation, or we do not have the data quality for the data that could support that certain investigation. Okay, so if you go to the next step, if now we have a data set that we want to use for the investigation, again with the user interface, with the tools UI, we can do transformations on the data right in place, right in this framework supported by an intuitive user interface. We can do the data wrangling that is important for the users. This is the place to add some data as well. We can use an extensive library of functionality to do transformations and even enrichments on the data. This is the place where we might want to add sentiment analytics on textual data, for example, or do some text functionality like collecting the important words and phrases from a text to judge what the text is about. We can preview the results and replay the transformations if you do not like them. As I said, this is an environment where we can experiment, and this enables the users this tool enables the users, if they find meaningful transformations or data cleansing capabilities are working out nice, then they can go against a subset of the data on a sample. They can test these functions, and if it works out, then they can apply to the full data set in Hadoop. Okay. So transformations can be done with the help of the tool on a massive scale without writing programs, using functionality from a predefined set of transformations. And that makes it easier for a business analyst, for someone who is not capable of using data transformation tools from a command line to work with the data and to easily do the pre-processing of the data. And that can bring this 20-80 balance to the benefit, to change this balance to the benefit of the analysis of the data. So, and here comes the meat. Then what we have transformed, cleansed, the data that we have chosen can be now given to a discovery tool within this framework that is a intuitive, interactive visualization tool that works with two combined methods. One method is the normal BI methods to filter the data, and then the filtered data, just like we do in a data warehouse, then we can run textual search also on the data. So if there are textual elements in the data, then we can combine the BI filtering methods with an intuitive, powerful search functionality. It's, by the way, Google kind of search. I cannot tell it any other way because you understand we are working with synonyms here, stop words, and so on. So we are doing an intelligent search on the data to find new patterns, and therefore we are using a lot of visualization capabilities. The great thing, I think, is that when we are sharing this information with others in the form of snapshots or bookmarks or data stories, that is also available with the tool to set up data stories, basically screens of our findings, and then share it with the other users. Then we can go back and begin to work with the tool again. So begin to add up new data elements to our investigation, then visualize the meaning of those, and then doing transformations on them, bringing them into the investigation of the discovery, and share it with the other users. So I think the benefits are obvious. Such a framework can help the companies to leverage more of the company's analytic talents. So it is not only the data scientists who should be able to work with big data collected into a data lake. We are able to create teams for collective discovery where business users, business analysts, and data scientists can work together on different parts of the discovery. And also, I didn't speak yet about this, but if we have some findings, we can write it back to either a relational database or into Hadoop so that others can begin playing around with it. Sorry, how much time do I have? Okay, then I will use that. But I'm not showing the video because then I wouldn't have time for that. I think this is something that can help simplify the tools that we are working with today. I believe that the whole market is going into this direction. So all the vendors in the market would like to set up tools that can support different processes of data discovery within big data lakes. And the users will benefit a big time out of this change in the market. Is this the only thing that Oracle can bring to the table when it's about big data? Not really, because we have a few more differentiators when we are speaking about our big data ecosystem. One thing is that we are also producing so-called engineered systems, software and hardware combined together to enable not just the speed up of the analytic processes, but the speed up of implementing a big data system. So on the screen we have the big data appliance shown. That is an Oracle hardware, software engineered together, running Cloudera Enterprise, and also many of the Oracle analytic and data management tools that are added to Cloudera Enterprise to make life easier. This machine, by the way, can work in the customer's premises. So on site at the customer, but is also available as a public cloud service, and can also work as cloud at the customer. So we are delivering also these machines to the customers behind the customer's firewall. If the customer is concerned about the security of the data gathered on these machines, then this dilemma can be solved by cloud at the customer. So putting these software, hardware, engineered systems to the customer site is also available. We have a whole bunch of tools. I obviously do not have time to discuss them now, but for the preparation, analytics, and also to the data infrastructure, we have a lot of things to speak about. The only thing that I would like to do is to refer to that. We have on this platform many users, many use cases. We are now working with a lot of customers worldwide, but also in EMEA and also in my territory to work on use cases in banks, in telecommunication companies, in oil and gas companies, in retailers, in public sector, and the vertical applications that we are setting up along these exercises are then kind of boxed and come as use cases that can be customized to the need of the next customer. Okay, here's a slide about how many customers are we working with right now. And I think I have still 3 minutes, then I go along just a bit more and just mention one more thing. When I began to speak about that, how we are analyzing, how we are enabling with simple to use frameworks the analytics of big data reservoirs or data lakes. I was not mentioning, but very obvious, that these architectures are not standalone in the companies, but we expect these to work alongside the existing data infrastructure of the cooperation already. So many times the customers who we begin to speak with about setting up a data reservoir, setting up a data lake, are already having a data warehouse, existing business intelligence, business analytics capabilities associated with that. And we want to enable the users of those systems to also be able to work with the data in the data reservoir. And there we have a very nice tool enabling that. The name is Big Data SQL. Big Data SQL enables users who got used to working with SQL language to be able to turn to any kind of big data storage systems, HDFS, Hive, NoSQL databases, and be able to run SQL queries seamlessly on these platforms. What is more, they can also join the data within these data storage systems with data in their data warehouses, and they can look at a combined answer from these systems. Okay, and with this, this slide I'm finished. We would like to enable all the business users, the business analysts, and also give productive tools that are easy to use to the data scientists to be more productive in their environments. Thank you very much for your attention.